So this question wants us to work out the nth term of a quadratic sequence. So under the what do we know, then we know this is going to look like an squared plus bn plus c. So in other words, we need to find the values of the coefficients of a and b and the constant c for generating this sequence. Now we need to remember that n is the term number. So in other words, n would be worth 1 for that, 2 for that, 3 for that, 4 for that, and 5 for that. So basically, whatever this rule does, it has to turn the number 3 into 7. Whatever this rule does has to turn the number 5 into 21 and so forth. Now, because it's a quadratic sequence, we know that we're going to have to go to what's called the second level of differences. So we basically start with n as 1, 2, 3, 4, 5. The sequence was 1, 3, 7, 13, 21. Do the differences between them. So 2, 4, 6, 8. Then we have to go to the second level, so 2, 2, 2. And basically, if we divide that by 2, it tells us the value of a. So a is equal to 1, because 2 divided by 2 is 1. If this was going 4, 4, 4, then a would have a value of 2. So we now know the rule starts with 1n squared. So we can write down what 1n squared gives us. So n squared would be 1, 4, 9, 16, 25. The sequence we wanted, if we remember, was this. So we do the differences between what we've got and what we wanted. So 1 is 1, the difference is 0. 4 to become 3, we'd have to take away 1. 9 to become 7, we'd have to take away 2. 16 to become 13, we'd have to take away 3. And 25 to get to 21, we'd have to take away 4. Now, this is a linear sequence, and we can see that this part of the rule is a linear part. So we'd expect that once we found the quadratic part, the n squared part, then we'd expect a linear result here. And we can see that a linear sequence, well, here we know that we're going down 1, down 1, down 1, down 1. So from linear sequences, we know that going down in ones tells us that we're going to end up doing take away n, take away the n value. So take away the n value would give me negative 1, negative 2, negative 3, negative 4, negative 5. So we need to remember now that we're dealing with this linear sequence where n was worth 1, 2, 3, 4, 5. So we knew that if we were doing negative n, this is what we'd get. But we want the answer to be 0, negative 1, negative 2, negative 3, negative 4. So to get negative 1 to become 0, we have to add 1. To get that to become that, we have to add 1, add 1, add 1, add 1. So basically we've got all our components of our rule then. So the quadratic part, the squared part was just n squared. The linear part was negative n plus 1. And with this kind of work, because it involves algebraic expression, then we should check. So we have to check the answer. So let's say what happens when n is 3. So if n is 3, our rule says we're going to do 3 squared, take away 3, and then we're going to add 1. Well, 3 squared is 9, take away 3 is 6, add 1 gives us 7. And we can see from our rule, our third term, the answer should be 7. So our check kind of says that, yeah, we should be okay. So that's how we could do the nth term rule for a quadratic sequence by finding the second level of differences to tell us what the value of a is in the general rule for a sequence of quadratic type. And once we know that, work out how many n squareds gives us, and then look at the differences between the sequence we want and what the n squared part gave us, and then that's going to be a linear sequence. Work out the rule for that linear sequence, combine the two to give us our final answer.